Lupa lah nak tekan mute tadi. Okay, thank you for coming. Thank you to those who just come here. So to Sir Nazrin, actually we would like to ask your permission first for us to record this video. So this is will be viewed later by the rest of the students who couldn't come, or for the rest of the students who wants to make some revisions later. If you don't mind, kita nak record lah. Boleh ke?
Okay, Nek, boleh. Sure, no problem.
Okay, so in case if you want this video for your own keeping pun kita akan bagi nantilah. So it will take time since around 1 hour 50 minutes, 1 hour 30 minutes. So nanti lepas dah habis record nanti I will tell you lah. Thank you so much. So it's already 8:05 p.m. So without further ado, together with us is actually Sir Nazrin Zaki, shift plants engineer at GE Gas Power. So I will let Sir Nazrin to introduce himself and start the class. Thank you so much.
Okay, thanks to Mr. Hanif. You guys can hear? Boleh dengar?
Boleh.
Alright, okay.
Boleh.
Assalamualaikum and a very good evening, everyone. My name is Nazrin. You can call me Nazrin. And I have been invited by Unit 10 to deliver this industry sharing. Actually, not a lecture, it's just like a sharing knowledge. So actually, I have been informed tonight we have a combination of two classes from Mr. Hanif and Dr. Saiful Asmadi. So I guess more than 50% inside here. So actually, it's a big crowd I ever have and ever in my life by doing presentation in such a big group. So, but it's okay. It will be a good experience for me and also for all of you. So I welcome everyone for tonight's sessions. First of all, I would like to express my appreciation to Unit 10 for inviting me as a guest to deliver this lecture. So I have been approached by my ex-colleague, Mr. Hanif, so to give a lecture to you guys on the thermodynamic subjects. So actually I told to him I'm not good in lecturing. So lagi-lagi nak suruh ajar thermodynamics kan, with all the formulas, isentropic isothermal bagai tu. So that was my conversation with him last time but it's okay. I try my best because this is actually not my expertise to do to give a lecture. So my actual working, I'm no longer use all the formula thermodynamic inside the plant. We actually no longer use the formula only certain department, and because when we are going to carrier works, we have a separate department Macam thermodynamic, we have like macam performance or engineering department. Macam saya, I more to on operations So for me, my task is only to operate the power plants to deliver a smooth power output to the grid system, how to start the gas turbine, how to monitor the parameter, how to tackle the problem at site. That's it So kalau ada kita ada deviation on calculation ke apa, that is not my work we will give all that task to the performance or engineering department. Right. For tonight, I can share a little bit on my current work in power plant and how it relates with thermodynamic. So hopefully my sharing tonight will give some insightful information and open up your interest in thermodynamic subjects, and also maybe capture your punya interest to know more on power industry. So I try to make my best to make everyone not boring on my presentation. So if you guys have any question, just stop me ataupun boleh just ping dekat chat box tu, okay? Kalau dah okay, dah ready, boleh komen nombor 1 nak tengok dah ready ke belum.
Okay, ready.
Yeah.
Mana chat? Semua okay.
Yeah, okay.
Tu dah ada. Okay, cun.
Alright. Without further ado, we will proceed Okay. Okay, so let me introduce myself first. So my name Nazrin. You can call me Nazrin. So my education background, I graduated from Unit 10 lah. Saya pun bekas student Unit 10 lah. Graduated in 2014 in degree in mechanical engineering. And then I get my master in business administration, MBA. Not master in engineering, master in business administration. It's more towards the management punya side lah. So I managed to get my master in 2020 lah, during COVID time. And my professional experience, currently I'm working as a shift charge engineer at combined cycle power plant at Sarawak. I currently working at Sarawak, but now I cuti raya kan, cuti almost one month, so I can spend some time to prepare slide and to give some sharing with you guys. So in combined cycle power plant at Sarawak, I actually operating 2 blocks of combined cycle power plant. The power output for each block is about 400 megawatts. So we have 2 blocks, so total about 840 megawatts. And then in 2015 until 2020, I was an operation engineer at a coal-fired power plant. So basically, I have 2 experience in thermal plant. One is coal-fired, and I was working at TMB for almost 5 years. And now the current one is combined cycle power plant. And 2014 to 2015, I was a completion and turnover engineer in oil and gas industry, working at Sapura Energy last time at Lumut. This one, I'm more on the construction of the platform oil and gas. So during that time, the oil and gas industry, we have a crisis on the oil price drop. So should be in 2015, I should be promoted to the permanent staff, but due to the crisis, I just can be extend to the contract staff. So macam rasa tak secure kan. So masa tu pun ada vacant position dekat TMB. So I try apply and Alhamdulillah I managed to get the position. Alright. So if you guys can see gambar ni, so this is myself dekat dalam control room lah. So this is my daily routine lah. We'll sit inside the control room. So you can see the PC. We have 4 PC here. 4 PC here. This we call DCS to see to monitor all the parameters lah. The gas turbine, HRSG, boiler, steam turbine, and all the associated system lah. So everything we want to start up ke, kita nak apa, kalau ada apa-apa hiccups ke, ada deviations ke, so all we will apa ni buat dekat sini lah. Kita akan initiate semua dekat sini. And this one, the left side is my picture inside the HRSG, combined cycle punya boiler lah. It's different lah. Last time when I was working at TMB, boiler is because for coal-fired power plant, we are using fuel. We are using coal, arang batu, as a fuel, as a source of fuel. So here in combined cycle, we are using gas as a source fuel. So if you can see inside the boiler tubes here, is very clean lah. As compared to the coal plant punya boiler tube, memang kotor lah. Later I share with you guys lah, gambar dekat coal plant. And here the gambar bawah ni is inside the gas turbine punya compartment lah. This is inside the compressor inlet. So masa ni saya tak pakai apa ni safety helmet, so don't worry, this time is during shutdown, so everything is safe. Before we go inside the gas turbine, if we go inside the confined space, we will do isolation. Means that isolation means we do off all the power supply lah. We need to get a permit before we start the work, so everything is safe lah. So the gas turbine will not rotate lah. All right. And that's a little bit of background on myself. Right, we go to the introductions. These are the content that we'll be sharing to you guys. We have about six topic. power station information, and then we have a type of thermal plant in Malaysia. Gas turbine power plant, Brighton cycle, Rankine cycle, and also the deviation in Rankine cycle. Okay, we go to the first slide. Let me share a bit on the power plant in Malaysia. So for your information, this currently this I take from the single buyer punya website. So it is the latest on March 2023. So now in Malaysia we have a total capacity. This one include for gas capacity, coal capacity, and hydro capacity. Means that coal power plant and also combined cycle power plant and also hydro plant lah. So we have total about 25,000 megawatt. Okay, 25 gigawatt lah. Okay. So for information, currently the our electricity supply industry, ESI in Malaysia is actually heavily dependent on fossil fuel, mainly natural gas and also the coal. So approximately about 90% of the electricity demand in Malaysia, especially in Peninsular Malaysia, is supplied by the fossil fuel. So however, due to this reliance to the fossil fuel, the energy sector itself has been one of the industry that contribute to the most carbon emissions lah. And this carbon emission will impact to the environment. So in view to the national commitment to kita punya Paris Agreement in 2015 and decarbonization agenda, so Malaysia needs to shift lah from current punya plan. We need to shift to the renewable energy lah. So this one will be stage by stage lah. We going to shift to the renewable energy. So basically, we have SEDA in Malaysia, which is a Sustainable Energy Development Authority. So SEDA already shared their milestone in the past decade, as well as current and future efforts on the Malaysia punya renewable energy transition. So as to reduce the environmental impact, actually most of the country in the world have accepted to reduce or to stop the coal plant operation by stage lah, because coal plant emits and also contribute high emissions like NOx, nitrogen oxide, sulfur oxide, carbon dioxide. So this will be contribute to the global warming and also the climate changes. Also in Malaysia sekarang ni there is no new investment for constructing the new coal plant. So the latest ataupun the last one yang kita ada coal plant in Malaysia is dekat Jimah Power Plant dekat Port Dickson if not mistaken at Negeri Sembilan. So because we want to reduce the coal plant in Malaysia. So now we are moving towards the green energy lah. Kalau you guys pernah dengar sekarang semua orang sibuk cakap pasal green energy kan. So banyak kepada kita buat combined cycle plant. Sebab combined cycle plant ni kita bila pakai gas dia less emissions compared to bila kita pakai arang batu. And also we moving to build another hydro plant and also LSS large solar scale lah. Alright. Okay. This is a few power plant that we have in Malaysia. You can see here the PPA, SLA expiry year. So this one is dia punya macam tarikh luput lah for the power plants lah. So for example, this one I take TMB Jalan Majung. This is my former plant when I working in 2015 until 2020. So the expiry date for this power plant is in 2030 August. So we have a few more power plants in Malaysia. I guess more than 20 power plants that we have in Malaysia. We have here hydro, combined cycle, gas turbine, conventional thermal. Conventional thermal is a coal plant lah. This Jalan Manjung and also Tanjung Bin also is a coal plant. Coal plant. If you can see, the capacity for the coal plant is bigger lah. So the advantage of coal plant is capacity, the output tu memang besar lah. We can deliver a very high output to the grid system lah. Tapi bila satu plant shutdown, habis lah. Satu plant shutdown habis. Kita habis banyak megawatt lah. Tapi bila kita deliver, we can dispatch a very huge amount of power output. Kalau macam hydro, you can see hydro tak banyak sangat lah. 400 megawatt. Combined cycle ada yang the latest punya combined cycle at Johor and also satu lagi dekat Melaka can go up to 1000 plus megawatt. This one combined cycle plant lah. Alright. Solar pun tak berapa besar. Less than 200 megawatt lah. Alright. So we have here a few company that's operating the power plant. Like for example, in Peninsular Malaysia, we have a big giant, we call the GLC company, government link company, which is TNB, Tenaga Nasional Berhad. And also we have a IPP, independent power plant, like Malakoff, EDRA, and also YTL Power, also a few more. And at Borneo, in Sarawak, we have alone, Sarawak Energy alone, and also Sabah, SESB, Sabah Electricity Syndrome Berhad. Sabah SESB, actually they have a sharing with TMB lah. Tapi tak silap saya more on Sabah punya government state lah. I think 60% government state Sabah lah. Another 40% TMB. Alright. Okay, we go forward to type of thermal plant in Malaysia. So we have about four thermal plant in Malaysia. The first one is coal-fired power plant. So this is coal-fired power plant. So the main fuel source is the arang batu lah, the coal. So in Malaysia, we buy coal from Indonesia, mainly from Indonesia lah. Also a few from Russia, daripada South Africa pun ada. Tapi most of the coal we get from Indonesia. Okay, then we also have a combined cycle power plant. So kalau you guys nampak plant yang macam ni, this is combined cycle power plant lah. So this is the HRSG, the boiler. Inside here is the steam turbine, and also we have a gas turbine punya compartment lah. So combined cycle basically fueled by gas lah. So we have a pipeline. So like my power plant in Sarawak, our plant is just beside the Petronas punya plant lah. So we get the gas supply from the Petronas. Also we have a biomass and biogas plant. So biomass and biogas plant dekat Malaysia ni actually tak banyak lagi lah. So dia punya fuel source daripada ni lah, daripada apa ni, oil palm trunk, daripada the byproduct of the palm punya apa, pokok kelapa sawit. Ada sekarang ni dia pakai haiwan punya pellet lah, najis haiwan ada juga macam tu. And also we have a cogeneration power plant. So cogeneration power plant usually ada dekat oil and gas lah. So like Petronas, this is the dekat Pengerang. So power plant, they have their own power plant lah. Petronas, they have their own power plant. So they produce the electricity and also they produce the steam, and they will use back the electricity for their processing plant lah. So this is the cogeneration plant. So most of the cogen plant is at oil and gas industry or chemical industry lah. Alright. Kalau ada apa-apa soalan boleh tanya. Okay. We go to the next topic, which is the gas turbine power plant. Okay. Gas turbine power plant, actually we have two type. Number one, we have a simple cycle power plant, and the second one is combined cycle power plant. So simple cycle power plant is the component is compressor, combustion chamber, and turbine. So for simple cycle power plant, dia sampai sini je, sampai gas turbine saja. So the hot gases just waste to the stack. And for the combined cycle power plant, we will reuse back the hot gases, and then we will send to the HRSG. Send to the HRSG to what? To change the liquid state to the steam, and then send back to the steam turbine. So I share first the video so that you guys can understand. Okay, for the simple cycle power plant, so the hot gases will be end until here. So we not reuse the hot gases and send to the HRSG. So for combined cycle, we use the hot gases and send to HRSG and produce the superheated steam to send to the steam turbine. Okay. So let's move. We see what is the difference between simple cycle and also the combined cycle. So this one I get this information from the GE punya website. So simple cycle, if you can see here, the net output for the simple cycle is only 448. This we have two type of gas turbine, 9H01 and 9H02. So if we use simple cycle, the net output, the power that we can deliver to the grid only this amount lah. If you compare to the combined cycle, so the gas turbine, the hot gases, will send to the SRSG, and then we will produce a superheated steam, send to the steam turbine, and then we can get another output, additional output. This is the amount we can get until up to 838 megawatt. And then for a simple cycle, the net heat rate, okay, net heat rate is high compared to the combined cycle. Heat rate ni maksud dia the amount of energy that we required to produce 1 kilowatt hour of electricity. Maksudnya kita perlukan more energy to produce 1 kilowatt hour of electricity. So heat rate and efficiency is inversely proportional lah. If heat rate high and then the efficiency is low, we see the combined cycle. Heat rate low, efficiency high. Means that kita tak perlu energy yang tinggi untuk produce 1 kilowatt of energy lah, 1 kilowatt of electricity. So the efficiency will be high lah because we use less energy, less fuel. Okay. And then the RAM rate ni actually apa ya RAM rate? Rem rate ni kalau dalam power plant punya term, dia punya megawatt per minute lah. Kalau kita nak naik load, for example, we want from 0 megawatt to 100 megawatt. So dia punya rem rate dia, contoh this one, megawatt per minute, 60 megawatt per minute. You can go 60 megawatt per minute, same lah, sama, simple cycle dan combined cycle ni sama. Dia punya rem rate dia sama.
So Nazrin, we have some one student, Venkish, raised his hands. So Venkish, can you ask your questions?
Oh, okay, yeah, alright. Boleh tanya?
Venkish?
Ada soalan ke?
Ada soalan ke awak tekan tadi?
Ke tertekan?
Okay, tak apa. I assume dia tertekan. Okay, tak apa. Sorry,
Alright,
Sir Nazrin.
alright, tak apa. Okay, for simple cycle, dia punya startup time ni maksudnya kita nak dapatkan load lah from 0 to whatever load we want. The startup time tu very short lah, kita boleh dapat dengan cepat lah compare to combined cycle lah. Because combined cycle is complex, we have a lot of system, so dia punya startup time is dia ambil masa yang panjang sikit lah. Alright. Oh, lupa jap. Sorry. Okay, kalau kita tengok dekat sini, the difference between simple cycle and combined cycle. So efficiency for simple cycle is normally less lah compared to the combined cycle. Combined cycle we can go up to 60% dia punya efficiency. And the operation and maintenance cost for simple cycle is less lah compared to combined cycle. Because for combined cycle we have a lot of system. So the cost for the operations and the maintenance will be a little bit high compared to the simple cycle. So the output also for simple cycle less than 350 megawatt, and for combined cycle we can go more than 350 megawatt. Okay, now we go a little bit on the thermodynamic lah. So for combined cycle, for gas turbine, we are using a Brighton cycle. So here, how it works, you can see the state number 1, number 2, 3, and 4. So we can see here the PV diagram, pressure and volume. You can see here from number 1 to number 2, pressure here at low pressure to higher pressure, 1 to number 2. Here from compressor, from inlet compressor, this one from low pressure, and it will compress to the high pressure here, number 2. So here kalau kita tengok dekat sini, this is the actual lah dekat saya punya power plant. So here we get A supply, air akan masuk kat sini. So dekat sini is low pressure, compress until the high pressure. So temperature also will increase lah from 30 to here the inlet combustion chamber. We get to 542 degrees C. You see here, number 1 to number 2. Temperature also will going up. We can see the actual also same, 30 to 542. So here, from number 2 to number 3, this is the combustion chamber. So combustion chamber, here, combustion chamber. Okay, we go back to this picture. So this is the combustion chamber. So for my plant, so inside the combustion chamber, we have 2 combustor lah. Kalau nampak dekat sini, this is the fuel gas. This is number 1, we call EV, and this is number 2, we call SEV. So we have 2 supply of fuel gas. So at the second stage, the temperature will be more higher compare the first stage. So this is stage 2 to 3 for combustor to the turbine inlet here. 2 to 3. The pressure will remain the same here where the heat is added, and then the temperature number 2 to 3. If you can see the TS diagram, 2 to 3 when we put more heat inside, so the temperature will move or will going up, increase. So here to 995. Okay, from this number 3 to number 4. So here where the heat is rejected lah. So we can see the temperature pun akan drop lah here 3 to 4 here 3 to 4. So from 995 here the heat rejected to 647 47 degrees C lah. So these hot gases will be rejected to the HRSG lah. Akan send to HRSG. Okay, this is the PV diagram and the TS diagram lah. So number 1 to number 2 is the isentropic compression. So is where the compression inside the compressor. So the pressure will be increased, and also temperature also will be increased. Process number 2 to number 3 is isothermal heat addition, where we burn the fuel inside the combustion chamber, increase the heat, and the temperature will be increased. 3 to 4 is the isentropic expansion. The compressed and heated gas is expanded inside the turbine. And number 4 to number 1 is isothermal heat rejection, where we have the drop of the temperature. So let me show. Wait, I'll stop sharing. Boleh nampak ke gambar ni, power plant, overview of the combined cycle plant?
Boleh.
Alright. Okay, this is, we have a software lah to actually, for us lah, to actually check for the components. So here I can share with you guys. So this is my power plant in Sarawak lah, combined cycle power plant in Bintulu. So we have two block here, number 1 and number 2. So we zoom out. So this is the long pipe is the cooling water lah. Panjang cooling water memang pipeline dia panjang, is almost 2 kilometer lah. Kita ambil air laut daripada laut. Why we take a long distance of the pipeline? Because if you take a short distance, let's say just only 100 meter, so dia punya kedalaman dekat dengan plant ni akan lagi cetek kan. So we don't want any slush or any impurities to go inside the cooling pipe lah. So we take the seawater far away from the plant lah. So let me see some overview of this plant. Dah lama tak main benda ni, susah. Alright. Okay. Okay, this is the combined cycle power plant. As you guys can see, this is the HRSG, the boiler lah. And here is the gas turbine. Gas turbine here. But the steam turbine is located at this building. Steam turbine dekat sini. So kalau simple cycle, in my power plant also we have two options. We can dispatch in simple cycle mode, or we can dispatch on combined cycle mode. That one is depend on the national grid punya requirement lah. Kalau dia orang minta kita on just simple cycle, and then we only operate on simple cycle lah. If they want us to give more output, then we run combined cycle lah. So if simple cycle, we only run until here lah. So here we have a diverter damper over here. We have a diverter damper. Dia macam sini macam ada plate lah. So kalau simple cycle, we will close the diverter damper lah. We close the diverter damper. So the hot gases from the gas turbine will be expelled here lah. Kita akan discharge to the stack here. Okay. This is the simple cycle lah. Kita akan tutup diverter damper here. and then only the gas turbine will be operate. For steam turbine, we will not operate. So the wasted heat or the wasted hot gases will be discharged through this stack. We call as a bypass stack. Tapi bila kita run on the combined cycle power plant, we will open the diverter damper, and then the hot gases will move or will go inside this HRSG. So inside this HRSG, we have a bundle of tube. We have a bundle of tube. So from the saturated liquid, and then we have hot gases here, and then we'll produce a superheated steam, and then we will send to this steam turbine here. Right. So we try to go inside the gas turbine. Kita tengok macam mana dalam gas turbine. I need to zoom in. All right. So this, just now I mentioned that we have two stage of combustor, right? The EV and also the ACV combustor, the fuel gas. So this is the EV. So we have 24 combustor here, and also ACV also we have 24 combustor here. So we have a double combustor here lah. So yang ini combustion chamber, and sebelum ni is the compressor lah. We have compressor here. This one is the combustion chamber, and here we have turbine lah here. Turbine, and then the hot gases will run through this compartment, jalan ikut sini, and we will be sent out to the HRSG. Okay, sent to HRSG. All right. Okay. Yeah, I stop sharing. We go back to this slide. Okay, that is the Brighton cycle lah punya proses. All right, we go to the combined cycle. So combined cycle is a combination of the Brighton cycle here, and also we have a Rankine cycle for the steam cycle. So okay, point number one is the utilization of heat rejection from the gas power cycle. Means that the heat rejection from this gas turbine. This turbine as the heat source in the vapor power cycle. So usually we call as a combined cycle gas turbine. So for combined cycle, we include the component gas turbine. Okay, the gas turbine. This is the HRSG, or we call a boiler. Also, we have a steam turbine, and also we have the condenser. Okay. Also, for the overall plant efficiency for combined cycle is more better than compared to simple cycle. So normal in my operation condition at Sarawak, we will go for combined cycle lah. Biasa kalau dalam power plant ni, we will discharge, we will dispatch power output. Normally, we have a high demand during morning lah. So during morning, we have a SDC, Sarawak Dispatch Center. We'll call control room, and they request us to increase the load. So until afternoon, and then during evening, dah start petang tu malam tu, they will request us to reduce back the load lah. Because masa malam kita tak banyak sangat pakai apa tu load, so they request us to reduce back the load. Okay. Rankine cycle for reheat. And number one, modification, expansion in turbine is done in multiple stage. So from boiler to HP turbine, reheater, LP turbine, and to condenser. So I try to relate from the theoretical and also the actual at the plant lah. Okay, we go first from the here lah, from number one to number two lah, from condenser. Here is where the source of liquid lah, the saturated liquid start from here, and then we will pump using condensate extraction pump and also the boiler feed water pump inside the boiler. So inside the boiler, so we have the heat source right from the gas turbine. So the heat source tu akan masuk dalam boiler. So yang air yang sejuk tadi dia akan lalu, we have a bundle of tube inside the boiler. So bila air lalu, and then we get some energy, some heat input from the gas turbine. So we'll change the state lah from the saturated liquid to the apa ni superheated steam lah. So let me share you. We go first this one lah. So this is the condenser lah. Condenser. So condenser, kalau kita tengok kat sini, temperature dalam condenser ni kat hot well ni, this is dalam ni hot well is hot well ni air lah, dalam ni air. We have a dimming water. Dimming water is not same like normal water. Dimming water is treated water. Treated water. We treat the water from the water treatment plant, and then we send here. We have two source of water. Number one, we get from the steam turbine, condense here, condense from the steam, then condense become water. And also if you don't have enough water, we will get another supply, this one, demand water supply, to supply additional water. Because we must to maintain the hot well level. We cannot get low level, because if we have a low level, we can trip the steam turbine. We trip the pump. If one pump, let's say this pump trip, and everything will be gone. So we have to monitor the level. So if you can see the level of water at the temperature is around 38 degrees C. Kita tengok di sini 38 degrees C, and then we will send using the pump to the boiler. Send to the boiler. Okay. This from condenser pump kan, we will pump to the boiler. So we go to the boiler. Tapi before we go to the boiler, kita tengok ni dulu. Okay, dia akan hantar kat dalam ni. This is inside the boiler. We have apa ni? Kita ada drum lah. Before dia lalu masuk dalam boiler, kita akan simpan air tu dalam drum. So kita ada 3 jenis drum lah. We have a HP steam drum, IP steam drum, and LP steam drum. So from the condenser tadi, mula-mula dia akan hantar pergi ke this one, LP drum. Okay, from the LP drum, and then we will use the feed water pump. Okay, use the feed water pump, and then we will send to the IP and also HP drum. We have here IP economizer and HP economizer. So the temperature will increase lah. Temperature will increase. Kenapa dia increase? Sebab dia dah lalu dalam HRSG tu tadi, dalam tube HRSG tu tadi. So here from step number 1 to number 2, we can see the temperature sudah naik lah. We can see the TS diagram for the Rankine cycle. We can see the temperature also akan naik. Temperature akan naik. And then bila dah masuk dalam boiler at point number 2 to number 3, from boiler to the HP turbine, we see here. Okay, this is HRSG, heat recovery steam generator, this one. Ataupun kita panggil boiler lah. So this is the gas turbine tadi lah. Ni gas turbine tadi. So the hot gases here, we can see here, the hot gases, the temperature is about 600 degrees C. So dia akan release the hot gases tu, dia akan pass through the tube dalam ni. Dalam ni kita ada banyak tube lah. You can see here, superheated tube, number 2, number 3, number 4. Kita ada evaporator tube, kita ada economizer tube. So the hot gases will pass through all the poly tube, And then we can see the temperature will be increased lah. Tadi kita tengok daripada this one, if water pump, temperature dia dalam 127 degree C. So when this saturated liquid pass through this boiler tube, kita ada hot gases, so temperature dia akan naik lah. Akan naik, dia akan pass through, dia akan naik. So this one 352, and then naik lagi 442, and then go up to 550, and then here we have 515 degrees C. So why the temperatures drop here? Kenapa temperature drop here? Because here we have a spray water here. Spray water, the function of spray water is to control the temperature, the superator temperature. Kita ada limit of the temperature, so we don't want the temperature at this stage to be to go up. So we will give spray water to reduce back the temperature lah. And then it will go to final stage of the HP superator tube, and then the temperature will move up to almost 600 degrees C. So this temperature, the superator steam temperature, we will send to the HP turbine. Okay, send to HP turbine. Kita tengok from state number 2, okay, from state number 2 to state number 3, a drastic temperature increase, we send to HP turbine. So HP turbine temperature akan, okay, kita masuk ke turbine. Okay, from this, this is HP turbine, this is IP and LP turbine. So we send the high temperature just now, almost 600 degrees C. We send to HP turbine. So with a pressure almost 107 bar. So when we send the high pressure and also high temperature, and then spin the turbine blade after we use the energy, and then the temperature will reduce back lah, and also we will have a drop in the pressure. So this is we call as a cool reheat. Cool reheat. So kita tengok balik. So kita tengok balik dekat Rankine cycle tadi. HP turbine kan. So from 2 to 3, we go to HP turbine, the temperature will move up. And then after we use the energy inside the HP turbine to spin the turbine blade, so the energy will be released and it will drop back the temperature from number 3 to number 4. So that's why we can see here the temperature drop from 542 drop to 372 degrees C. Okay, so when the temperature and the pressure is dropped, we want to reheat back the energy or the temperature. So we will send back the steam to the boiler. So this is we call the core reheat. Core reheat send back to the boiler, and then okay, we go here. So this is the core reheat. Yang tadi keluar daripada HP turbine kan, the one that sent out from the HP turbine, we will send back to the HRSG. Okay, we call it a reheater. We send back to the reheater tube to increase back the temperature and also the pressure. So then send back to the IP steam turbine and also LP steam turbine. All right, here we see here. Okay, this is the IP turbine. So we send for IP turbine, we have a double flow. We send from top and from the ball, from the from the below one. So we reheat back the temperature, and we can see the temperature for this Rankine cycle from number 4 to number 5 will be increased back now, right? Okay, after we use the energy inside the IP and LP turbine, so after the turbine blade is rotate, spin, the steam use a lot of energy to spin the turbine, and then it will be discharged or expelled to the condenser. So dia akan buang balik ke condenser here, condenser. So when we discharge the steam, so to the condenser, so it will be the drastic drop from the 500 something to less than 100 degrees C, and it will change the superheated steam to saturated liquid. So macam mana, how does the superheated steam change to saturated liquid? Macam mana dia boleh tiba-tiba daripada steam boleh jadi air? So we see this video. This is in Japanese language. All right. Okay. This is the condenser. This is condenser, and the top is the turbine lah, LP turbine. Okay. So just now we can see the steam. The steam expelled to the condenser chamber. So how the superheated steam change to liquid state? We have this heat exchanger here using the seawater, the cooling water. So bila air sejuk masuk kat sini, sini panas. Bila dia kena dengan air sejuk, so dia akan condense lah. Condense akan jadi air balik, change to liquid state, right? Alright. So dah almost 1 jam So far okay ke?
Okay, sir.
Okay Boleh faham tak? Boleh nampak tak macam mana?
Boleh. Saya pun baru
Okay.
nampak
Okay,
ni.
sir.
Alright. So maybe we can have a 5-minute break. Kita rehat sekejap 5 minit. Till we come back after 5 minutes.
Sure, kan?
Okay. Nak minum air sekejap. Alright.
Sila.
Nanti kita jumpa lagi.
Okay. Meanwhile, you guys are taking breaks. So, actually, for both my class and for Dr. Saiful class, I have prepared some questions. Okay, prepared some questions in the Brightons. So, actually, it's just one questions lah. One questions referring to the vapor power cycles, Rankine cycle lah. So later you guys can try and do it. Okay. So I have discussed with Dr. Saiful. If let's say you guys receive good marks for that, it can be included as part of your carry mark lah. So maybe you can discuss with Dr. Saiful later. Okay. So for those who wants to add up my class, my subject code is MEHD2014. MEHD2014. But never mind. Later I will remind Dr. Saiful to ensure you guys to enter my class. So you guys can self-enroll to my class also. Okay. So we have one quizzes for you guys to do. Okay. And the due for it is up until the end of our final exam. So you have plenty of time. So might as well you use it as part of your exercise also. Okay. So on my part, I don't mind, but I think Dr. Saiful would really glad if you guys can do it also lah. Okay, thank you. So right now we have some few more minutes for Sir Nazrin to take a rest for a while. Okay. I forgot to let Sir Nazrin know. Actually, we also have a guest from several TNB staff also, Mr. Amir Yusof, Sir Hanafi, and also person from Derau. Kau kerja kat mana lupa ah? Dialog ah. We also have people from Dialog also. Just to come and hear to
Bukan.
your class lah. Derau bukan Bukan Dialog
Bukan.
Oh, okay. Okay. Dilium bukan
Dulu Didium, sekarang Dimension Beat.
Oh, okay. Okay. Semua ni
Oh,
actually
also we also have Mr. Hanafi,
yeah, we also have Mr. Hanafi from TNB HQ in case if you guys wanna ask something about TNB.
Who's
This is the
Hanafi?
time. Who's Hanafi?
Who's
Mr.
Hanafi?
Hanafi.
Maybe Mr. Hanafi can introduce himself.
That one is also Mr. Nazrin alias. Also, we are all actually alumni lah from Unitan. And some of us might also become was actually students from Dr. Saiful
Mr. Hanafi is my best friend lah last time. Dia budak sekolah TNB, Hanafi. Dulu kalau zaman study, we all refer refer dekat dia lah.
Oh. Berapa umur
Perhaps
dia?
Okay, we can continue Hanif.
Okay, thank you.
Sekarang nampak ni screen ni ke yang Navis work?
Nampak je.
Alright, okay. So let me share a little bit on the background of the power plant. Just now I share to you guys on the condenser and also the cooling water kan. So here we can see the pipeline, the cooling water pipeline. So this is the cooling water pipeline, the red color. So we have a cooling water pump house. So here we have, inside here we have a pump lah. You can go inside here. You can see pipe, we can see pump here. Okay. So here we have a pump. We have a 5 pump. So from this pump, we will run the pump and send the cooling water pump, the seawater, to the condenser. Okay, kita tengok the pipeline. We need to see underground. Kalau tengok underground boleh nampak. So we see the underground pipeline. Okay. If you see here, the pipeline, okay, this pipeline, okay, this one. So this pipeline go to inside this one. This is we call the condenser inlet, seawater cooling water. Seawater cooling for the condenser inlet. This one go inside, the cool water go inside, and this is the outlet. After we condense the steam, so the seawater will come out here lah, this line. This one go in, this one come out. So we go inside. Okay. So here we have inlet seawater. We have two. We have two, one and this one, another one. The second go further inside. Okay, we go inside the condenser. Okay, if you guys can see the video just now, I share how the steam convert to the liquid. So we have the seawater cooling here, inlet, go inside the condenser. So the turbine is over here. Dia punya arrangement turbine lain sikit daripada gambar tadi. So turbine kita dekat sini. The turbine is over here. So this is our turbine lah. This is our turbine lah. Dia punya arrangement turbine ni macam ni, dia side by side lah. So turbine here, go inside the condenser. So turbine, the steam will expel here, and then we have a bundle of pipeline of the seawater. So there is a heat transfer from the hot and then change to liquid state lah. So after change to liquid state, so we send the water using this pump lah. This we call the CEP pump, condensate extraction pump. So we send to the boiler drum. Okay, send to boiler drum before the water reheat inside the boiler. All right. So daripada tadi condenser, the water we will send using the CEP, condensation extraction pump. We will send to this boiler drum, this one, LP drum. This is the LP drum. So from the LP drum, we have a bundle of tube and pipeline, tube inside the HRSG. So we go to the down comer, and then we'll be reheat here. That's why we can see the change of the temperature from 30 to 100. And then we will send from the LP turbine, we will use this feed water pump. This is the feed water pump. This is the feed water pump. We have two pumps, so only one running. So we use a feed water pump to send back to the IP and also HP drum, this one. IP and HP drum. All right. Okay. Okay, let's move to this slide just now. All right. Okay, this is the final topic lah, the deviation in the Rankine cycle. So basically, whatever we learn theoretically and also the actual is different lah. Dalam paper memang semua nampak okay je kan. So actually, in actual condition, we will have a few losses lah, few losses. So dia punya, let's say dalam paper we say like 580 degrees C. Maybe actual we cannot achieve at 580 degrees C. Maybe we only can achieve 560 degrees C. So due to several conditions, several factors. One of it is fluid friction, heat losses, and also water steam cycle loss. So this will be impact to the plant efficiency and also the power output lah. So also will be contribute to the high cost of the operation and also maintenance cost. So this is on the left side. This is the boiler for the coal power plant. So coal power plant. So we use coal as a source of fuel to burn inside the boiler. So inside this boiler, just now, like I mentioned before, the coal plant and also the combined cycle plant is different. So coal plant, we will have a very dirty, the tube surface will be very dirty compared to the combined cycle using gas. So very clean lah. So for example, this tube, superior tube for this coal plant, we can see a slagging and also a falling. So this will affect the heat transfer when we fire inside this boiler. So when we have this slagging and falling, so inside the tube we have water, right? From the saturated liquid. So we want to transfer the heat from the combustion to transfer the heat inside the tube. So it will affect because of this slagging. So that's why we cannot achieve the temperature that we want lah. So this is a few example of the main root cause why we cannot achieve the ideal cycle of the Rankine cycle. So what we need to do if we have this kind of problem? So for coal power plant, we have the soup blower. Boleh nampak ke dia YouTube ni?
Boleh.
Nampak sir.
Alright. So this is the animation for the coal-fired power plant. So inside the boiler, because the thinness of the boiler tube, so we have to strategize the soup blower operations. So we have a certain period of time we need to run the soup blower to clean the boiler tubes. Kalau dekat combined cycle power plant, we don't have the soup blower because the tube is clean. So only for coal plant, we have this soup blower as to clear out the slagging and falling and to improve back the heat transfer and to get back the temperature. So this is how the soup blower operations now. So by using this soup blower, we'll remove all the slagging and falling, and we can get back a good heat transfer inside the boiler tube. All right. Okay, other than that, the losses that we have, like this one. Okay. So this is example of the leaking at the HP pipeline. So yang ni pun akan affect kita punya cycle lah, Rankine cycle. This one is the steam loss. You can see here, steam loss. So basically, in actual, we will not get a good as per inside the paper. So that's why we, as a working in a team, so we need to have a proper inspection, to do work down, to check all the system working well. All right. Right. Okay. I think that's all from me. Any question? Okay ke, boleh faham ke? Ada nampak sikit tak macam mana how dia relates dengan power plant?
Any questions that we like to ask?
Kalau faham boleh komen satu.
Okay. So back to my instruction just now. So there are questions provided to you guys in Brightons. Okay, so these questions are actually for vapor power cycles, which is the Rankine cycles. It is in my Brighton. So for Dr. Saiful's class, in case if you have trouble finding my my Brightons, you can ask Dr. Saiful later. Okay, or if you can just straight away go now, just search my subject code MEHD2014. Okay, thermodynamics. And the due date for the quizzes, the questions are actually up until your final exams, final exams, final paper of the final exams. So let's just assume that you can use that questions as part of your revisions. Okay, so without further ado, I would like to thank Sir Nazrin and the rest of the guests right here, right now, like Sir Nazrin, Sir Hanafi, Sir Amir Helmi from TMB. I would like to ask your permissions to all students to at least open your video cam so we can take pictures and to wrap up our class. Boleh ke buka maybe Nazrin boleh tutup kot sharing screen.
Oh, okay. Sekejap.
Lepas tu boleh buka lah. We all can open our yes.
So hopefully
Okay.
you guys gain something from this sharing and get some knowledge on the power plant, type of power plant, and also how the thermodynamics relates to the power plant. So if you guys have anything, just can connect me at LinkedIn. They search Nazrin Zaki. Ataupun boleh email saya kalau nak tanya apa-apa tips kerja ke apa kan. Just can ping me lah.
Later I will share Nazrin's LinkedIn. So for those especially degree students yang dah nak grad ke apa, maybe this networking lah. I can say that it is part of the networking you can have. Okay. Nazrin, hang tahu ke macam mana nak tangkap gambar ni? Print screen ke apa
Oh, sekejap. Aku snap ni, snipping tool je lah. Sekejap
Okay lah.
ready.
Hang boleh je, tak
Ready.
apa. Kita ada banyak lagi students yang tengah cuba nak buka ni. Anyway, thank you guys for your cooperations, especially to my class and to Dr. Saiful class. If there is any hiccup, I'm so sorry about that. This is our first semester having this type of class. InsyaAllah for next semester, you will also have this kind of class also, insyaAllah. Okay. Dah ke? Yin?
Okay, dah.
Anak dengan lain-lain tak buka ke? Hang punya apa ni? Video buka sekali. Nazrin, Pai, Rau.
Hopefully korang dapat sesuatu daripada sharing ni.
InsyaAllah. Okay ke Yin? Sambil makan.
Sekali lagi kejap.
Okay.
Okay, 1, 2, 3.
Okay. Okay. Okay ke? Okay, thank you so much all.
Okay, thank you everyone.
Thank you, Sir Nazrin. And thank you all. Okay, bye-bye.
Assalamualaikum. Thank you, sir.
Assalamualaikum. Thank you, welcome.
Okay, welcome.
Assalamualaikum, sir. Thank you.
Okay, welcome.
Thank you, sir.
You're welcome.
Sama.
Thank you, Ian.
Right,
Esok
Nat.
nanti okay, bye.
Right.
Bye.
Kau kat mana ni, Nip?
Aku kat lab.
Oh,
Pukul 10. Aku ada kawan aku pun tengah mengajar kat luar tu, so aku teman dia sekali lah.
oh, okay. Alright. Esok ada kelas
Tadi esok cuti. Kau Wesak kan?
Oh, lupa.
Itulah.
Okay.
Tu aku tak boleh nak buat Khamis tu. Last hari ni lah.
Okay, Nip tadi. Boleh faham aku share ni?
Best.
Okay.
Akulah yang banyak faham. Itulah aku rasa aku pun kena banyak pergi ke sana lah.
Aku pun takut korang
Baru-baru
tak
ni
faham
aku
tu.
pergi
Aku buka apa tu software tu kan nak bagi nampak sikit macam mana power plant dia punya link dia.
Baru-baru ni pun aku pergi SEB je, tapi tak dia punya HQ je lah.
Pergi
Mungkin ada peluang nanti aku pergi sana. SEB Sarawak.
Bila kau pergi? Kuching.
Kuching. Awal nak kata awal SEM ni macam mana nak cakap awal SEM ni?
Yalah,
Bulan 2 hari tu kot. Macam tu.
Plan aku tu plan SEB lah, tapi
Oh ya?
plan Sarawak Energy, tapi because they using our GE punya system kan. So dalam kontrak tu termasuk sekali dengan dia orang minta kita untuk operate dengan maintenance sekali for a few years lah.
Okay lah tu rezeki. Hang cuti habis bila?
Lagi 2 minggu.
2 minggu. Okay lah. Kat sini sebenarnya hujan lebat ni. Aku rasa aku keluar dululah. Hang pun keluar sekali lah.
Okay. Bye.
Bye. Bye.
Hi, Nazrin.